and tonight's lecture on revealing art, science, and the technical evaluation of paintings. It is my pleasure to introduce tonight's speaker, Carol Christensen. Carol is Senior Painting Conservator. I have to get that right. I made a mistake. It's not curator, it's conservator at the National Gallery of Art. And she also heads a private painting conservation studio. Carol has been at NGA since 1981, which I think is before the East Wing was constructed. No, not quite. A few years after. She earned a BA in art history from Skidmore and an MS in painting conservation from the University of Delaware in a collaborative program with the Winterthur Museum. She also studied German restoration techniques as a Fulbright scholar at the Gebäude Gallery in Berlin. She has published widely on the materials and techniques of many old masters, including Raphael, Frans Hals, Van Dyck, Gainsborough, and on early Netherlandish and Sienese Renaissance artists. She is a professional associate of the American Institute of Conservation. She served AIC as project chair for the Painting Group catalog and as editor of the AIC newsletter. The title of her talk tonight is Revealing Art, Science in the Technical Examination of Paintings. Please join me in welcoming Carol to the podium. I don't know if it's on.
I don't think it's on. Okay. I'd like to thank the Philosophical Society of Washington for inviting me here tonight to speak to you about how science can aid in the study of paintings and in their conservation. I'll begin by explaining a few terms I'll be using during this presentation. Many people may not be aware that painting conservation is a field in which knowledge of chemistry is as important as artistic skill, since we must understand how our techniques and materials will affect the physical structure of works of art. The materials we use must not discolor or become insoluble and therefore difficult to remove. Our procedures are based on scientific research into stable varnishes in painting materials, consolidants, and supports, as required by the American Institute of Conservation's Code of Ethics and Standards of Practice. Similarly, our present standards for the packing and transport of art are the result of studies on the effect of changes in relative humidity, vibration, and temperature on paintings. Professionals who are graduate school trained and follow these guidelines are called conservators in the United States, to distinguish them from untrained restorers whose concern may be more about present appearance than future stability. The paint that conservators apply to damaged areas is referred to as in-painting, that is, stable paint that does not extend onto areas of original paint. When I use the terms repaint or retouching, I am talking about old repairs made with unstable or insoluble materials, often applied over large areas of original paint, an unacceptable practice in our field. Because the role of science in painting conservation is so broad, tonight I will limit my discussion to a description of how scientific tools help conservators examine paintings and sometimes influence their conservation treatment. The careful examination of paintings is important, since conservators cannot make informed treatment decisions without first understanding a painting's materials and present physical state, including how it may have changed over time. Since the 19th century, when advances in science allowed scholars to look at paintings in a way that had not been possible earlier, interest in the technical examination of paintings has only grown. In the 1930s, for the first time, conservators, art historians, and scientists began collaborative research under the leadership of George Stout at Harvard's Fogg Art Museum. This cooperative approach continues to produce the most important information and conservation protocols in our field. The technical examination of a painting can involve three broad categories of analysis, depending on what questions need to be answered. The first category is spectroscopy, which uses the interaction of light with a sample to examine specific wavelength regions, including visible, ultraviolet, infrared, and X radiation. The information is often available through the use of a variety of imaging techniques. This is the preliminary investigative tool. The second category is microscopy, involving the use of optical lenses to magnify a sample or a series of magnetic fields used as lenses to focus a beam of electrons on a sample. The third category is chromatography, in which a sample composed of an unknown mixture of materials is separated into its individual components by the partitioning of a component via selective adsorption and desorption as the mixture passes over a stationary phase. Moving on from this dull slide of machines and alphabet soup, I'd like to explain some of these techniques in greater detail. Ultraviolet radiation, used since the 1920s, was the earliest form of technical examination of paintings beyond careful examination under magnification, and it is still used today. The usual source of UV radiation is an ultraviolet lamp, familiar to some of you as a black light from your disco days. Used in a darkened room, it emits long-wave UV radiation in the range of 320 to 400 nanometers, which has the ability to excite visible fluorescence in many organic materials, including natural resin varnishes, paint media, and some pigments. Usually these materials fluoresce in different colors and intensities that provide valuable information about the surface condition of a work of art. For example, in this painting of Judith by Jan Metzies, the presence of an aged natural resin varnish is apparent due to its strong, slightly opaque, characteristically greenish fluorescence. On the left, you see the painting partially cleaned, with the old darkened varnish still in place in the circled areas. In the image on the right, the same painting viewed in ultraviolet light, the greenish fluorescence of the aged natural resin varnish is visible in the circled areas. With its ability to render the varnish layers more visible, UV light examination can determine whether a painting has been unevenly cleaned in the past and whether traces of an old, earlier varnish remain in some areas. It also makes visible many old repairs, since under UV light they are often seen as dark purple or black patches scattered across the surface. In the image on the right, these retouches are visible as black spots in the chest of Judith. They appear black because the old repairs were carried out in different media and pigments that fluoresce much less than the aged varnish and original oil paint. When the varnish layers are very aged, their fluorescence may conceal repairs that lie below. Some materials on the market, used in the past by unscrupulous restorers, can be added to varnish to intentionally mask retouching over repairs and therefore disguise the true condition of a damaged painting. Another imaging technique that can provide valuable information uses infrared light, the wavelength of warm rays just beyond the range of the red band of visible light. The area of most interest in studying paintings is the near-infrared, 780 to 3,000 nanometers, in which many paints that are opaque to visible light become transparent, allowing the examiner to look below the surface to underdrawing or underpainting. This technique, called infrared reflectography, works best on paintings in which the artist has sketched with black pigment on a support covered with white priming. The camera captures the difference in the absorption of heat by the black pigments and its reflectance by the white background priming layer. However, since the human eye cannot detect infrared radiation, an imaging device is needed to render the information visible. In modern setups, this is a computer screen. The first infrared images appeared in 1910, and they were further developed during World War I for aerial surveillance. By the 1950s, the technique was widely used to examine paintings. A Franz Hals portrait is seen on the left before conservation. In the middle is a 1954 black and white infrared photo that revealed a black hat in the underpaint, although not very clearly. Infrared imaging was greatly advanced during the 1960s by the Dutch physicist Van Asperen de Boer. An image made using his system appears on the right. Aware that longer wavelength infrared radiation would be more effective at penetrating blue and green paint films, he adapted an industrial infrared camera, basically a TV camera with an infrared sensitive Vidicon tube, for the study of paintings. This equipment was able to convert infrared radiation into electrical signals that could be read as a live image on a television screen. Because the thermal imaging cameras used for infrared reflectography are relatively low resolution, information can only be captured over small areas a few inches wide in sequence, and with the Vidicon system, image capture was a very slow process. To achieve a high-quality image, many individual captures had to be made over small areas of the painting, and later mosaicked together following an overlapping grid pattern across the surface. Hundreds of individual reflectograms might have to be collected to form one overall image if the painting was large. After capture, each individual image on the monitor screen had to be photographed, printed, and then assembled into the final mosaic, which was again photographed. The Vidicon image was certainly an improvement over the old infrared photograph, but edge distortion was a problem, so that a uniform image without edge lines could not be obtained. Now, however, technological improvements allow digital collection and assembly using Adobe Photoshop, which has greatly speeded up the process. In the last 20 years, other thermal imaging devices originally developed for the military that use infrared semiconductor sensors have further improved infrared images. The first of these improved systems, using a platinum silicide detector, was introduced at the National Gallery, Washington, in the 1990s. But other systems with an even greater range of sensitivity are now in use at our museum. These systems were found to improve paint penetration by extending sensitivity further into the infrared range and eliminating geometric distortions that were a problem in the older technologies. The use of passband filters, which allow narrow band wavelengths to pass through while blocking all frequencies outside the set range, has further improved these infrared images, and this research is still ongoing. The images obtained with our present system are extremely clear. Here you see a panel painting from around 1500 by the Netherlandish painter Bernard van Orley and its infrared reflectogram assembly. Infrared reflectography shows many changes from first sketch to final paint layer. In the undersketch, done with black ink on a white ground, the young Christ stands on a circular raised platform that was eventually painted out. In the upper section of the architecture above the figures, shallow arches were drawn underneath the horizontal lintels on either side of the portico. In this slide, you can see the hatched underdrawing in one of the figures and the earlier sketch for the arches in the building more clearly. You can, and you can see those right here. This is the arch form that is repeated back here. So this originally would have been a three-arched structure rather than a coffered ceiling. When comparing this painting with others by the artist, we discovered that his later dated paintings are all underdrawn in black chalk rather than ink, and you can tell that by the shape of the strokes. And they have many fewer changes in the sketching stage. This information led scholars to assign a very early date for this undated work, when the 18-year-old artist was still relatively unsure of himself, trying out a variety of ideas by sketching on the priming layer before deciding on a final composition. In this case, infrared reflectography allowed us to place the painting more exactly within the artist's development. So, to summarize, we use UV light to look at the upper layer of a painting structure and infrared reflectography to look beneath the paint layer to the underdrawing or underpainting beneath. If we want to look even deeper into the painting, we turn to X-radiography. Familiar to all as a medical imaging technique, it is now a routine tool in examining paintings. First used in the 1930s for that purpose, it reveals simultaneously all the layers of a painting's physical structure. Although the images were originally recorded on sheets of film, they are now collected digitally and displayed on a monitor. The painting is placed on an electronic easel, and the X-ray source is aimed at small areas of the painting in sequence. The X-ray beam can be controlled by adjusting the length of exposure, the kilovolts, or the current. The X-ray source remains stationary, while the painting on its easel slides left or right, up or down, along remotely controlled tracks. The distance of the X-ray source from the painting is calculated to avoid edge distortion in the captured image. As most of you are probably aware, the X-radiograph image results from the varying ability of materials to absorb X-rays, depending on their density and thickness. For example, X-rays cannot penetrate lead, so wherever lead is present, the image is lighter relative to how much lead is present. Since the most commonly used white pigment before the 20th century was lead white, all paint mixed with lead white appears as relatively light shades in the X-radiograph, whereas areas where little or no lead white paint was used appear darker or even black. In this painting by Tiepolo, the surface image is on the right and the X-radiograph on the left. It is an excellent example of what an X-radiograph can tell us. The artist originally painted the woman holding an open fan, but changed his mind so that in the final image the fan is closed. Because the underlying fan was painted using a great deal of lead white paint, the hidden image is clearly visible in the radiograph. In this case, the radiograph allows us to understand the artist's creative process, which is in itself useful, but it can also be helpful in cases where there are two or more versions of the same painting. The first version is always more valuable than the copy, so it is useful to ascertain which is which. Artists' changes appear only in the first version, so the X-radiograph can answer the question of primacy. I'd like to point out some other information that can be gathered from this image. The broad light bands near the edges of the picture reflect the greater density of the wood stretcher bars around which the canvas is stretched, and that would be these areas. The nails with which the canvas was attached to the stretcher appear white due to their high relative density. The canvas weave is faintly apparent as well, its pattern made visible by the tinted priming with a little lead white in it. The black border around the extreme edges tells us that the painting has been expanded. Whoops, let me go back. And that is these areas. The original canvas was covered with a priming layer to isolate the oil paint from the canvas, and this priming layer contained some lead white pigment, hence the relatively light color of the original areas of the painting. At a much later unknown date, the canvas was taken off its original stretcher and adhered to another slightly bigger piece of canvas, creating an unpainted border of lining canvas. This package of two attached canvases was remounted on a larger stretcher by wrapping the larger lining canvas around the larger stretcher bars and fastening the canvas to the stretcher with tacks. The expanded area, which appears as a black border around the edges of the X-radiograph, was retouched to match the color of the original background, but it was not primed with the same lead white containing priming as the original, so it appears black in the X-radiograph. The information that the painting was expanded is important because in some cases, the conservator, after discussion with the curator, might choose to return the painting to its original dimensions, which more accurately reflect the artist's original intent. Other black areas at the bottom and top right indicate paint losses that are not apparent on the surface due to skillful retouching, but that are visible in the X-radiograph due to the differing materials in the repaired and original areas. So Here, you see a tear that has been repaired and inpainted, and these little black areas are all little paint losses that are not visible on the surface. In this way, the X-radiograph becomes at once a document of a painting's history and a roadmap of damage and old repairs that is valuable to the conservator when treating the painting. One disadvantage of X-radiography is that if the painting was primed or lined with a thick layer of lead white and the paint above it is thinly applied with little lead white, the thick lead white priming obscures any image from the paint layer, so the result would be a uniform white field with no information. One solution is a technique called Neutron activation autoradiography, which was used successfully by several institutions, notably the Metropolitan Museum, New York, and the Gemälde Gallery, Berlin. It can characterize paint layers lying above a lead-white ground, and it reveals paint with large amounts of dark umber, copper blues and greens, vermilion, and orpiment pigments that do not show up well in X-radiographs. The technique involves inducing transient radioactivity in the paint structure by exposing it to a beam of low-energy thermal neutrons. X-ray film is then placed in contact with the paint surface at set intervals corresponding to the half-lives of typical elements found in pigments, resulting in images of distinct exposure patterns created by the differing rates of decay of the elements in the pigments present. Occasionally, dramatic discoveries have been made using this tool. When this painting by Van Dyck was X-rayed, an upside-down portrait head was faintly visible under the surface composition, but the image was very unclear. In the image at the right, you see the X-radiograph. In this slide, the inverted X-radiograph is on the left. The portrait head is visible at the top center, but it is still not too readable. On the right, the eighth plate of film revealed a bone-black sketch clearly recognizable as a self-portrait of the artist. A typical image might reveal a complete underpainting in umber paint, while a later film might show changes made primarily in copper blue. The downside of neutron activation autoradiography is that it can take a long time, depending on the pigments, involving minutes, days, or even weeks after the initial exposure, and it also involves making the painting radioactive, although the institutions who use the technique do not feel that this damaged the painting in any way. Because of the neutron beam, it also requires transport of the painting to a reactor facility and its extended stay there. Obviously, this is not a practical analytical technique for most museums. Identification of the wood type in panel supports for paintings is often useful in our field. Until the mid-15th century, wood was the most common support for paintings, and microscopic examination has enabled identification of these different wood types. The creation of databases of this information and their cross-referencing with geographic locations has enabled scholars to show artists' preference for specific species in certain regions. So, for example, we now know that Netherlandish artists of the 15th century employed Baltic oak exclusively. This knowledge can help pinpoint where a painting by an unknown artist was made, or it can suggest a painting is a forgery if the wood is incorrect for that artist or school. Dendrochronology, used to date wood panel supports, is another valuable tool. The goal is to offer an earliest possible date for a painting based on the felling date for the tree. The dating is based on the biological regularity of the ring series in trees from temperate zones, comparing the ring sequences of undated wood with those of wood of known age and position in time. There are separate chronologies from a variety of regions, all of which are mapped in an overlapping system of individual curves for the establishment of master chronologies. The determination of ring widths can be done by looking at the panel edges under magnification, or sometimes by studying X-radiographs of end-grain sections. If dendrochronology indicates the tree was probably was felled in 1500, we know that the painting could not have been done before that date, and that it was probably done around 1505 or 1510, allowing for a typical period of wood seasoning. This can be helpful in investigating art historical issues such as authorship. It can also be somewhat disheartening, as in the case of this National Gallery painting, originally thought to be painted by the 16th century Netherlandish artist Jan van Hemessen, working in the 1550s. However, Dendrochronology identified a probable felling date for the tree of 1584, plus or minus 2 years, 22 years after the death of the artist, so now the painting is unattributed. On the plus side, it can help determine whether a signed but undated work is from an artist's early or late period, leading to a better understanding of the evolution of his style. Optical microscopy of the surface of a painting is an essential tool for the conservator in assessing condition, artist's technique, and for differentiating original from later restoration. Most conservators use low-power binocular microscopes to scan the paint surface, usually at 10 to 50 times magnification, before treating paintings. Under magnification, the conservator can distinguish original areas from repainted ones, since repaint typically spans cracks in the aged paint layer, while in areas of original paint, the cracking occurred years after the paint was applied, so no paint lies in the cracks. In this painting by Boucher, seen at the top left, magnification and X-radiography together confirmed that the signature and date on the painting were false. I've drawn a yellow line on the PowerPoint image on the left side of the painting to show where an old repaired tear in the skirt is not visible on the surface. In the detail of the X-radiograph, seen at the top right, the repaired tear shows up as a jagged black line. Beneath that image is a detail of the infrared reflectogram assembly, which shows the black repaint covering the tear and the false signature on top of it. In the magnified image of the signature at the lower right, it is clear that the paint goes across cracks in the paint layer, further proof that it is not original. And I'd like to apologize here for this horrible shot of the painting under magnification. At the time, we didn't have the use of our regular system, so we decided to try the crummy little magnifier that comes with our cell phones. And we got a pretty good image out of that. These images turned out to be crucial in solving a troublesome art historical issue. The false date was 1746. If this date were correct, the portrait would have been painted by the artist while still in his teens, yet it looked much more like the accomplished portraits the artist created in middle age. Documentary evidence indicated that at this early date, Monsieur Bergeret, who commissioned the painting, presumably of his first wife, had not yet become a patron of the artist. Based on our technical investigation, we now assume that the painting was actually painted in 1766, not 1746, and that it is a portrait of the patron's second wife rather than his first. We think that some years later, when the painting was torn, it was repaired by a restorer who misread the remnants of the original date, repainting the date as 1746. Mystery solved. Microscopy of several types is central to the identification of pigment samples, as well as typical painting supports such as wood and fabric. Pigments also can be identified non-invasively by instrumental analysis. However, the latter method cannot pinpoint where in the painting's stratigraphy the pigment occurs. Study of cross-section samples can determine location within stratigraphy, but the method is invasive, requiring a pinhead-sized sample that cannot be put back on the painting. Both tools are used at the National Gallery, depending on what questions need to be answered. Pigment identification is a valuable tool in differentiating original areas of paintings from later editions and also in identifying forgeries. Specific pigments only became available after historically documented dates or were not in use in later times. So, for example, if the red in a purported Italian Renaissance painting is painted with cadmium pigment, the painting is not from the Renaissance, since cadmium red only became commercially available in the 20th century. Pigment samples are studied using polarized light microscopy. Dispersed samples of the pigment are identified by comparison with known reference samples based on particle size, shape, inclusions, refractive index, fluorescence, and many, many other features. At the National Gallery, this work is done by our research scientists, but in smaller museums, conservators may do it themselves. Samples are also taken as cross-sections, which, when mounted in resin, cured and polished, can be viewed under the microscope in reflected visible light and ultraviolet light to reveal all layers from the varnish on top to the lowest layer of priming. Cast cross-sections can be used later for scanning electron microscopy, energy dispersive spectroscopy, EDS analysis, for confirmation of results, or for medium analysis of distinct layers using gas chromatography mass spectrometry. GCMS is a very accurate medium analysis tool that was used, for example, in 2011 to unmask this forgery at London's Courtauld Institute. The paint in a genre scene purported to be by Dirk Baboeren, a 17th century Dutch artist, contained bakelite, confirming suspicions that it was painted by Hans van Meegeren, who also forged many Vermeers during the 1930s and 40s. He is the only forger we know of who used this material, so it acts as a fingerprint for his work. In fact, these days it is nearly impossible to successfully forge old master paintings, because even if the forger uses an old canvas and the correct pigments for the period, modern paints do not contain the trace elements present in old paints, and these trace elements are readily detected by various types of instrumental analysis. Before discussing two case histories, I'll touch on a few forms of instrumental analysis used by our scientists at the National Gallery when specific information about painting materials is needed. Please note, however, that since I am not a scientist, I can't give detailed descriptions of how these instruments operate. My scientist colleagues at the National Gallery told me to say to you, they push a button and a miracle happens. But I think I can do a little better than that. In recent years, investigations have trended toward analytical approaches that are non-invasive. Depending on the nature of the question and of the art object, this is not always possible. Typically, those analytical instruments used for the examination of inorganics are based on the detection of characteristic X-rays emitted from elements found in the materials, and they include scanning electron microscopy with energy dispersive X-ray spectroscopy, and X-ray fluorescence spectroscopy. XRF, I'm just going to use the initials, has the advantage of being non-invasive, and the handheld devices now available allow analysis to be carried out in situ. They are aimed at a few square millimeters of a painting's surface, close to but not touching it, and the resulting elemental profile provides a basis from which pigment inferences are drawn. An example of how XRF is used to learn more about a painting is this landscape painted by Van Gogh just a few months before his death in 1890. On the top left, you see the painting as it looks today. Van Gogh described this landscape as full of pink and white flowers, but today all the flowers are white. When the painting was taken out of its frame, conservators noticed that along the edges, where the paint had been covered by the lip of the frame and therefore protected from light, some of the flowers were a pale, bright pink. The logical assumption was that the pink flowers not covered by the frame edge had faded to white because they must have been painted with a light fugitive pink or red pigment. But how many, and which ones? A very patient conservation scientist used XRF to analyze all 387 flowers present in the composition, identifying the element bromine in 1/3. Bromine is present in eosine dye, the colorant in a paint called Geranium Lake, newly available at the time Van Gogh painted this landscape and later discovered to fade in light. On the bottom right, you see a photoshopped image of what the painting might have looked like before the fading. The circled areas are where the pink flowers are most evident. For analysis of inorganics, National Gallery scientists use gas chromatography and mass spectrometry. More recently, the addition of Fourier transform infrared spectroscopy, Raman spectroscopy, fiber optic reflection spectroscopy, and hyperspectral imaging have each come to play important roles in the characterization of all manner of artists' materials. Both FORS and hyperspectral imaging are non-invasive. Of course, all of these tools work best when the data is interpreted with collaboration among scientists, conservators, and art historians. To show you how these analytical tools work together to reveal important information about a painting that helps determine its conservation treatment, let's return to the Hals painting, entitled, not surprisingly, Portrait of a Man. You may remember that earlier in this lecture, I presented infrared images of this painting that revealed a hat was present in the underpaint. However, in the surface image, there is no hat, and the man's hairstyle is much longer and curlier. Ideally, conservation treatment seeks to recapture the appearance of the painting when it left the artist's studio. So it was important to determine whether that hat was part of the original composition. There were several possibilities. Option 1 was that the artist had painted the hat, but later changed his mind and covered it up, in which case we would leave the surface image in place. Option 2 was that the hat was original, but was painted out at a later unknown date by a restorer. Option 3 was that both the underlying hat and the surface image without the hat were later restorations, and another lower image existed beneath these two layers. To determine as best we could what was the painting's original state, we used a combination of technical analysis and documentary research to make what we feel is an accurate guess about the portrait's original appearance. The first step was to determine whether the hat was part of the original composition and if it were well enough preserved to be revealed. If that were the case, we would also need to determine whether the later paint could be removed without damaging the original paint layer. If the hat were not part of the original composition, it would have to be painted out. Art historical research suggested that changes in costume and props in portraits by Hals are a fairly common phenomenon. And here you see two examples of those changes. Hals' rather rough, vigorous style of painting, although fashionable during the mid-17th century, fell out of favor in succeeding years, and later restorers often gentrified the images to make them more palatable to Victorian art connoisseurs. In the portrait of Verdonk, seen at the lower left before conservation and at the lower right after conservation, the sitter's unkempt hair and the jawbone he holds in his hand are references to Samson, who killed 1,000 Philistines with a jawbone. There was a moralizing message here that would have been understood by a 17th century Dutch audience. But the later restorer, unaware of the meaning of the image, covered the wild hair with a hat and converted the jawbone to a wine glass, probably to make the painting more attractive to a prospective purchaser. In 1928, the repaint was removed and the painting was returned to its original state. Another reason for occasional repainting in Hals's portraits is that they often remained in the possession of the families who commissioned them, and these families sometimes hired artists to update the style of dress. 4 paint cross-sections taken in different areas corresponding to the underlying position of the hat determined that the hat lay in the lowest paint layer. So it was definitely painted by Hals himself, and no other composition lay beneath it. However, it was still unclear whether Hals himself painted out the hat or if it was done by a later hand. Documentary research turned up this engraving, made no more than 20 years after the painting. At that time, the hat was already painted out, and the hairstyle was short, unlike the longer style in the surface image. This might lead to the conclusion that Hals himself painted out the hat. However, paint cross-sections told a different story. When examined under magnification in ultraviolet light, 2 fluorescing layers of varnish, seen here as the thinner lower yellow line in the cross-section, were revealed between the hat and the subsequent paint layers. In between these 2 paint layers was a thick layer of varnish, not visible in this slide, but evident at higher magnification, suggesting the passage of time. Since varnishes are only applied after a painting is finished and about to leave the artist's studio, This information suggested that the painting left Hals's studio with the sitter wearing a hat. The engraving showed that no more than 20 years later, at which time the engraver had died, the hat had been painted out. It was not painted out by Hals, though. Although he was alive for 15 years after this portrait was done, he famously never accommodated his clients by changing his compositions. Our curator discovered through costume research that this style of hat, popular during the 1640s, was a bad boy style favored by young men who spent a lot of time drinking and gambling, a sort of 18th century version of this modern look. It is possible that the sitter might have regretted his fashion choice of 10 to 20 years earlier and requested that the hat be painted out. What was still puzzling, however, was that there was no trace of this intermediate hatless version between the original hat and the upper layers of paint. Pigment analysis solved this mystery. The background paint masking the hat was found to contain Prussian blue, now mostly faded due to its admixture with a large amount of lead white, which catalyzes fading in the blue. Prussian blue was not available until 75 years after the painter left the artist's studio, so it could not have been applied by Hals or by the person who painted out the hat in the 17th century. We therefore formed the following hypothesis. The painting left the artist's studio with the sitter wearing a hat. No more than 20 years later, the hat was painted out by another artist. Since the engraver died 20 years after the painting was done, we know the repaint could have been not have been applied after that date. At some point after 1725, when the pigment Prussian blue became available, a restorer tried to clean the painting to remove its dirty varnish. The 17th century repaint probably came off with the yellowed varnish, revealing the unwanted hat, so the restorer covered it up with repaint containing Prussian blue. If we return to the image of one of the cross sections, you can see a thick yellow fluorescing layer above the 18th century repaint. This is actually 7 layers of varnish with dust in between each one, suggesting the passage of many years, probably more than 100 years, since revarnishing often occurs every 10 to 20 years when the surface becomes dull. Above these layers lay the background paint and the longer hairstyle of the surface image. This surface layer of background paint contained viridian, a green pigment not available before 1862. We think that by the 19th century, the Prussian blue in the background repaint had faded, leaving an unsightly pink halo of lead white and iron red pigment around the sitter's head. Because the painting came on the art market around this time, it was probably again repainted with a mixture containing viridian to disguise the halo in preparation for sale. Since, as far as we could determine, the hat was originally part of the portrait, we removed the several layers of repaint, revealing the original composition for the first time in 350 years. Fortunately, the hat was well enough preserved to make this possible. The second of my 2 case studies is this landscape by Paul Gauguin. In preparation for removing a yellowed varnish from the painting that was distorting the original cool tones, we did, and this is after treatment, so it doesn't look yellow now. We did a thorough examination to answer the following questions. First, why is the composition here somewhat awkward? It has a claustrophobic feeling with few of the devices artists normally use to create a sense of depth within the picture space. Also, if you look closely, you will notice that many elements of the composition are curiously unresolved. For example, the reflections in the water do not mirror the surrounding landscape. The cloud formations are strange, and the odd small pyramidal hills in the middle distance seem indistinct, almost a part of the bare tree limbs in front of them. It's important to point out that in this image, this is actually a photograph taken in the same place about 10 years ago, and this was painted in the late winter, and these trees are all bare. And this is his rendering of those bare trees. So these shapes, which seem at first to relate to the trees, are not trees. Those are actually hills behind the trees. And this becomes important later on. Technical analysis and some observations borrowed from neuroscience research on non-conscious thinking provide plausible hypotheses for these phenomena. A little background on the artist. Although he is best known for his Tahitian works, Gauguin spent several years in Brittany in northern France before shipping out to Tahiti. In Brittany, as later in Tahiti, he was searching for a more primitive and, in his mind at least, purer culture. He was also poor and could live there cheaply. This picture, signed and dated 1888, was painted during the late winter of that year, during Gauguin's second visit to the Breton village of Pont-Aven. The town's situation on the Aven River, bisected here by a long rocky outcrop, creates a natural mill race that enabled the eventual construction of at least 12 mills that became the economic mainstay of the town before artists and tourists began to visit it. During these late winter and early spring months, Gauguin tried out a lot of new ideas, and this seemingly unremarkable and somewhat awkward impressionist picture actually contains the seeds of many practices which would become hallmarks of his later style. We might say he was in the process of transitioning from impressionist painting to a more avant-garde style. This painting is in fact a document of his state of artistic irresolution, since it contains 3 separate compositions painted one on top of the other within a short period of time. The various compositions were documented using a combination of imaging techniques and analysis of cross-section paint samples. Here you see the X-radiograph of Brittany landscape, and actually you see 2 X-radiographs. This is actually the X-radiograph, and I've outlined the forms here just so you can see more clearly the underlying images. In the image on the right, the lines in 2 different colors represent 2 differing underlying compositions. The focus of the clearer of the 2 is a large building on the right, outlined here in yellow. Another fainter group of buildings is outlined in green. This green group includes a church spire in the sky on the right, and on the left, the large steep roof of a building whose lower section is hidden by a rise of land. This image is confusing because we are looking at several different sketches at the same time. For example, the diagonal area of white in the middle of the image may represent the waterfall or outlet of a mill complex. That would be this. But the house on the right is too large to fit within that composition, so we must assume these 2 ideas aren't contained within the same sketch. The difficulty with interpreting these images is that we don't know for sure where in the layering these different compositions occur. However, we can make an educated guess that both are in the lower layer of the composition because of the black outlines around the buildings. You see that most clearly right here. This comes from Gauguin's practice of painting around but not quite up to the edges of his sketched lines. Because there is less lead-containing paint in these thinner areas, they appear black. If the forms were created in the upper layers of paint, and therefore later in the creative process, there would be lots of paint beneath the edges of forms, so there would be no black outlines. So we can assume these 2 sketches occurred early in the artist's creative process. A separate composition is revealed through the use of hyperspectral infrared imaging, which sometimes more clearly shows complex paint changes through the use of narrow spectral band filters. Here, a false color image, rather than traditional infrared imaging, is found to better visualize the separate underlying image. This image involves a mill complex in the middle distance with a mill wheel on the right. The blue in the false color image is mostly due to the presence of cobalt pigment. As in X-radiography, this image may also show several different ideas from different layers within the painting, although none seen here seem to relate to the images visible in the X-radiograph. We assume that because this composition shares certain features with the surface image, it lies between the images visible in the X-radiograph and the surface image, so somewhat closer. It's sort of the middle of the 3 images. When the underlying compositions were discovered, it was first thought that Brittany landscape was painted over an older painting due to Gauguin's impoverished circumstances at the time. However, examination of paint cross-sections revealed a different story. This paint cross-section was taken from a spot corresponding to where several overlaid compositional elements occur. At the bottom is the priming layer, followed by successive layers of paint from the various compositions. When a new painting is painted over a dry earlier painting, the demarcations between the paint layers are quite defined. However, in this sample, there is no clear hard line of demarcation between successive paint layers. The interfaces are in some cases completely indistinct, the result of wet-into-wet paint application. In other places, the interfaces are distinct but softly blurred, as would be the case if paint were applied over a lower, incompletely dry but still tacky layer. Drying time of paint varies according to the pigment, the amount of medium mixed with it, and to some degree the relative humidity in its environment, but research has shown that in general it is firm after about 3 days. The most likely explanation for the combination of wet-into-wet paint and wet-over-soft paint is that Gauguin painted Brittany landscape with its many alterations over the course of 2 to 4 days. The only completely firm line visible in the cross-section is a top stroke of orange paint, which you see right there. A highlight in the hill, probably added in the studio weeks after he had finished the main part of the painting outdoors. Here you see an image of the infrared reflectogram of the painting on the right with the X-radiograph on the left. What the infrared reflectogram and X-radiograph make clear is that all of the compositions share the same sky-hill interface. The fact that these sketches were made within a short time frame might suggest that Gauguin moved his easel to at least 3 different sites within the space of a few days, but it is very unlikely that all 3 locations would have the same hill line. A more plausible explanation is that the artist began the painting in the studio, which was his common practice, and then carried it outside, changing the composition at several different sites over the course of a few days. Gauguin's determination to reuse the sky hill line of his initial studio sketch in all the succeeding compositions may account for some of the awkwardness of the composition. A combination of X-radiography, paint cross-section study, and hyperspectral imaging led us to propose a probable order to the compositions, a sort of peek into the artist's mind as he created the picture. However, the presence of several strange compositional devices was still puzzling. Among these were the small pyramidal hills in the right middle distance, which are not a part of the topography of Pont-Aven. One cannot really call them a stylistic eccentricity of the artist, since they don't appear in any other paintings by Gauguin. One explanation for their origins may be found in recent neuroscience research by Queter and Dehaene, which proposed 3 distinct modes of consciousness. In addition to conscious awareness, which requires 2 self-reinforcing patterns of brain activity in different areas of the cortex, Queter and Dehaene proposed 2 different types of non-conscious perception, subliminal and preconscious processing. We are all familiar with subliminal processing, in which an image is so briefly presented among many others that one does not remember seeing it. Preconscious processing involves an opposite set of conditions. The image is in full view and therefore strongly processed by the visual cortex, yet the viewer's attention is directed elsewhere. Other areas of the cortex that might have processed the image, thereby bringing it to the conscious level, are involved in a different task, so that the distracted viewer is not aware of the image, although it can influence his subsequent actions. The several paint cross-sections taken from Brittany landscape revealed astoundingly that Gauguin did not block out the lower compositions when he painted on top of them, exhibiting a rather extraordinary ability to focus on the new composition despite the presence of the earlier one in front of him. Using the Sky Hill demarcation line as an anchor, he freely altered the compositions below that line. However, at a preconscious level, he must have been aware of the peaked roofs of the underlying farmhouses because he echoes them in the strangely shaped hills that appear nowhere else in his work. According to Queter and Dehaene's theory, the fact that the cerebral cortex is processing the information results in a priming effect that caused Gauguin to non-consciously echo the underlying farm roof shapes, shown here as yellow lines, in the hills of his altered composition, here outlined in green. A similar phenomenon exists in the lack of concurrence between the landscape and its reflection in the Avon River. The tall, narrow profile of the reflection mirrors the shape of the steeple in the underpaint, only visible in the X-radiograph, rather than the line of hills and trees on the surface. The resulting ambiguity would not have bothered Gauguin, since in his writings he described his painting process as a sort of violent birth arising out of a deep well of unconscious feeling, with the lack of clarity between forms adding a desirable sense of mystery to his works. This painting is an early example of that preference. These case histories reveal how the tools of science not only help us understand the creative process of the artist, but also are occasionally crucial in determining the proper course of conservation treatment. The increasingly common trend of collaboration among scientists, conservators, and art historians, now occurring not only within the United States but internationally, has resulted in constantly expanding our knowledge about how paintings were made, their subsequent history, and how to best preserve them for the future. Thank you.
We have the podium for a minute?
Yes.
I think you took my comments there.
Oh. Oh, I did. I'm sorry. You have to sort them out now. Okay. Should I go sit down, or should I stay up here?
No, stay here. We're going to have questions. I just have to remember what I'm supposed to say about that. Well, in any case, so we have time for some questions, and there are people with microphones. If you'll raise your hand to ask a question and keep it up, please stand when the microphone comes to you. Tell us your name and whether you're a member of the society. No penalty if you're not, but please join if you're not. And
My name is John Birch. I'm not a member. I had a question about the effects of the ultraviolet on the painting itself. In most museums, they say you can't use, they don't want to keep it, they don't want to let ultraviolet light in from outside, and they don't want you to use flash cameras and stuff like that. It seems like your technologies might be even more damaging than a short period.
The concern about ultraviolet light is long-term exposure through a window, and when we're looking at paintings with an ultraviolet light, we are probably looking at them for 3 minutes. The other thing is that ultraviolet light is very damaging to works of art on paper, but when pigments are bound in an oil medium, most of them, aside from the red lake pigments, with that example I showed you from Van Gogh, most of them are not sensitive to ultraviolet light. And in fact, in the National Gallery, we do allow flash cameras. Yeah, so it's not really a concern for the amount of time that we're using it and for oil paintings. It is a concern for works of art on paper.
Yeah.
Thanks. Pardon, I guess we're supposed to stand. Thank you, that was lovely.
Name?
How do you,
Are you a
Frank
member of
Robert,
the society?
and I'm a member, yes.
Okay.
And now to the question. When you're deciding where to focus your efforts in these works, how do you, without the technology, come to the decision of which ones will be fruitful for applying it, and how do you then protect them with chromatography and so forth?
Well, at the National Gallery, we are in the process of writing systematic catalogs for every collection of paintings. So there's one for Dutch 17th century paintings, one for early Netherlandish painting, and so forth. And as part of these catalogs, there's an individual entry on each painting, and the first part of it is a technical note. We have examined every single painting with infrared reflectography and X-radiography and looked at it with UV. It's really important in understanding paintings' histories because sometimes they've been cut down or changed, and so you really can't talk about the history of the painting if you don't look at it with these technical tools. In terms of doing cross-section analysis, microscopy and so forth, that is a sort of another step. that we would only take in specific instances when we have questions about paintings that we're going to treat.
Dave Freeman, non-member. I got hooked on your saying that you find dust in paint layers, and I'm thinking Sherlock Holmes' geological thoughts from the environment where the painting was made, from the chimney down the street, from the nature of the studio. And I'm wondering if you have looked at that with some of the techniques you mentioned.
Well, we haven't, no, I don't think we've looked at the kind of dust. And, you know, we have to be very careful with this, too, because, as you say, the environment can influence how much dust is on a painting. So in one place, a painting can have no layer of dust on top of the varnish if it's been there for 20 years, and in another place it might have been somewhere for a week and gotten dust on it. So we can't use the dust alone as an indication of the passage of time, but the fact that there were so many layers, 7 layers of varnish with dust in between, that does suggest the passage of a big amount of time.
Hello, my name's Isaac Schomer. I am a member, and my question is, with the painting with the man with the hat, it seemed like you were able to identify Prussian blue as well as another paint, and you were also able to identify the specific point in the thickness in terms of where it was. I'm wondering which technique was able to provide you such
That is
specificity.
Pigment identification based on cross sections.
Okay.
And then sometimes we always do 2 forms of analysis. So we might back that up with SEM or XRD. We use XRF too, but that is, you can't tell where in the layer structure the pigment is. So while it's useful if, say, you're trying to figure out what a surface on a bronze is, it's not as useful in paintings because the layer structure is so complex, and it's important for us to know where the pigment is within the structure.
Okay, thank you.
Hi, Kenneth Rothschild, supporter, not a member. So, with all these techniques over the years, there's probably been scientific improvements, so you can get better and better analysis. So my question goes to, how often has the gallery been surprised where they thought they had something or they thought they understood a painting and something comes up with a newer technique where they've been mistaken for quite a while?
Oh, the National Gallery is never mistaken.
No, but I mean, there must be a history of finding things out.
Well, I mean, in the example of these 2 paintings, yes, you know, in both cases there were other underlying images that no one was aware of when the paintings were acquired.
You don't find forgeries or?
Well, we have one painting that is, we don't know what it is. It's a Vermeer, and it's an atypical Vermeer, and it is not, it's not called a forgery. It's called follower in the style of Vermeer, or a school of Vermeer, but Vermeer had no school, so draw your own conclusion.
The reason I asked is, on 2020, very frequently, there's been programs showing art forgery being pretty widespread. So,
well, it's a question of not everyone examines their paintings. You know, we're lucky that we have, our conservation division has 50 people in it, and probably 12 of those are research scientists. We have a lot of instruments that can detect this stuff, but not everybody, you know, has access to that. And a lot of these techniques have just been developed in the last 20 years. And so a lot of forgeries that may have been done, for example, Van Meegeren, who is a very famous forger that created a lot of Vermeers that were bought by the Nazi hierarchy, the higher-ups, at that time, there was no way of identifying that these were forgeries because we didn't have all this instrumental analysis. There was a very famous trial in which he was going to be convicted of trying to sneak art treasures out of the country. And he said, no, I didn't do it. I painted them myself. And he actually painted the picture in front of the jury to show them that he could do it. And then, very soon afterwards, I think they were able to identify with like these primitive means of analysis that were available at the time, that there was a bakelite component. I think it's easier to forge 20th century works because those things have the same pigment. The pigments are available today, and you can't find trace elements that would differentiate a pigment from 1980 from a pigment from 1960 necessarily. So.
Hi, Ileana Peters. I'm not a member. I was wondering, you focused on oil paintings. Are similar techniques used for other types of medium? So, like, if you're restoring a chapel somewhere or something like that, would you use a similar type?
Yes. I think a lot of these techniques are used on manuscript illuminations, works of art on paper. They do X-radiography of works of art on paper using beta radiographs, and it's not for the image, it's for the watermark, because the watermark can tell you a lot about the date of the painting and where it was, where the paper was manufactured.
Okay. George Bailey, visitor today. I have particular interest if you have discovered or know more of painters who have purposely done overpainting in a way where they've tried to keep the underlying image sort of a secret or part of a puzzle as such, meaning that part of the creative aspect of painting is to present something but also have something hidden.
No.
And keep that a secret.
No,
I
I don't.
haven't tried that yet.
I don't know of that. I guess that would be, you couldn't really publicize that because it's not visible. So, no, I don't know of anything like that.
Hi, Nancy Shung. I'm a visitor. You might have already mentioned, it might be one of the anecdotes you've already shared, but I was wondering if there's one particular project or investigation that you did that really stands out to you that's most memorable.
Well, I think the Franz Hals was a pretty memorable experience, just because it was really so puzzling. It isn't always that you can solve these problems. There are some times when there's just not enough information to make a decision, and I think it was just very rewarding. We felt like we really, we solved the mystery, and we were able to present the painting as it once looked. Sometimes that's not possible. I mean, it's very hard to figure out how a painting looked when it left the painter's studio. So that to me was probably one of the best, most rewarding experiences I've had.
Yes, Ronnie Perry, I'm a visitor. I wonder if you could review for us the difference between a conservator and a restorer, and what exactly would trigger the services of each.
Well, in Europe, people that do what I do are called picture restorers. In the United States, when the modern profession of conservator started in the 1930s, the people who were the founding members of the profession felt that it was a profession that was sort of shrouded in secrecy. People had their ways of doing things, so they wouldn't share it with other practitioners. It was a craft-based profession, and I think that the founders wanted to make it more of a profession, a real profession, and to emphasize scholarship and sharing among professionals. And so that's why they chose the name Conservator to emphasize that our job is not to just make the picture look good for today, but to use materials that will ensure that the painting always looks good, to preserve it and conserve it, not just to restore it in a sort of a way that doesn't understand the history of the painting or the use of stable materials.
Thank you. I'm Dave Rabinowitz. I'm a member. And I remember several years ago when the Sistine Chapel was restored, the ceiling, there was substantial controversy because it
Yes.
looked very different. Have you
Yes.
had controversy because of some of your conservation restorations?
Yes, not since I've been at the National Gallery, but when I've been at the National Gallery for many years, and just when I just arrived, a controversy had just happened over Rembrandt's Mill, the famous painting by Rembrandt, The Mill. It has seemed to me, watching these kinds of controversies from a viewpoint of 30 years, that most of these controversies are politically motivated. And they really don't have that much to do with painting restoration or painting conservation. There are political issues always behind these things, and people jockeying for position and to getting work for their studio, and it really has more to do with that.
So we have another.
I'm Barbara Hyde. I'm a visitor. One of your slides showed a Jackson Pollock, and I'm wondering what are the conservation issues in 20th century art? What attracts you to look at a painting in terms of conservation, especially things that aren't varnished? Could you address that a little bit?
Well, I'll address it as best I can, but I have to emphasize that I'm a conservator of old master paintings, and we have another person in our staff who just does contemporary paintings. They are completely different structure, as you're probably aware. They're often on canvas that has no priming layer. They use acrylic materials or any other number of odd materials. So in a way, they're more like, I'm not kidding. I went to a conference in Ottawa where people had painted paintings, a big painting that said "eat" in ground up spinach. And after a long time, or not even, probably a few years, the spinach had faded, and the question was, do you repaint the painting with spinach? And I just thought, no, this is not for me. I'm going back to old master paintings. It isn't, it's, a lot of these paintings are done with unconventional materials, and a lot of the analysis that is done on these paintings is to determine whether it's acrylic, what kinds of odd mixtures, mayonnaise and so forth may have been mixed in with the paint, because you need to have that information in treating the paintings. It's completely different treating a modern picture because, as you say, they're not varnished, so you're not using solvents to remove layers of varnish. They are almost more like textiles, and you do techniques that are more grime removal techniques, aqueous techniques.
So we have time for one or two more. I thought I saw somebody up front here.
Yes, Bill Davis, a visitor. Question, you referred several times to the painting at the point that it left the artist's studio. But under a circumstance where a painting was revised by an artist after it left the studio, how do you decide what constitutes the original?
You never, if the artist repainted his own picture, you leave that in place. That is his final decision. We have a famous painting at the National Gallery, the Feast of the Gods, which was painted by Bellini, a famous early Renaissance artist, and then the patron who commissioned the painting wanted to match another painting that she had in the room, so she commissioned another artist to repaint it, Titian. So the whole top of the top half of the painting is repainted by Titian, and no one is going to take off Titian's repaint to reveal a Bellini. But you can see the original composition of Bellini in the X-rays. So we have it all documented. And I should say that's part of treating a painting, is that you photograph the painting before the treatment, during the treatment, and after the treatment. Because at the National Gallery, we believe in invisible repainting. We don't believe in showing any of the damage. We feel that the painting is a visual illusion, that it's its function, and if you reveal the damage, you're impairing the function of the picture, which is to make a visual illusion. But it is still important for our code of ethics to have some documentation of the true state of the picture. So we do always take a picture of the painting when we've removed all the varnished and repaints, and that is in our file and can be seen by anybody, so you can see what the true state of the picture is.
Judy Bear, a visitor. I'm curious as to how much it costs to have a thorough analysis of a painting done. If someone were to buy a multi-million-dollar painting on auction somewhere, and they wanted to put it through a process to certify that there was no forgery, how much would that kind of process cost?
I would think it would cost more than $1,000. I'm not really sure because we have an in-house staff, but there are private concerns that can do that and do that for people acquiring paintings.
Well, I have one question, and it goes to the dust question, but instead, do you ever do a pollen analysis to go with your tree analysis? Because, you know, pollen is very particular to geographical areas, seasons, and times, and there's been a lot of pollen studies.
Yeah, I haven't come across that, but I will mention it to our research scientists. Yeah, I don't know how would it show up?
Yeah, it would be. And
That's
yeah,
interesting.
You can look at that stuff.
It's possible. It could be a geographic locator.
So we may have to have somebody come and talk about conserving modern paintings.
Yes, I will recommend my colleague, the National Gallery.
So in appreciation for your wonderful lecture tonight, which combined art and science, I'd like to present you with this signed copy of the announcement of your talk. On behalf of all the members of the Philosophical Society and all our visitors, thank you very much.
Thank you.